So for the rest of this chapter, we're going to be looking at transformations. And there are basically 4 transformations you need to be familiar with. The first one we're going to talk about today is a dilation. But first we need to know what a transformation is. Basically, a transformation is an operation that maps an original geometric figure called the pre-image onto a new figure called the image. So on a graph, you're going to take some type of geometric figure, triangle, quadrilateral, something like that, and you're going to transform it, right? You're going to change it somehow. So the first way we're going to change it is by dilating it. That's what this video is about. So specifically, the dilation, which is one of the 4 transformations we're going to look at. The dilation uses scale factor, and what it does is it either enlarges the image or it reduces the image. All right, so we know a little about scale factor already. So what you need to just to double check yourself is when the scale factor is greater than 1, then that's going to make the image bigger, okay? That would be enlarging the image. The image will be enlarged. Okay, and when the scale factor is less than 1 or smaller than 1, then the image is going to be reduced. All right, so whatever figure you're talking about, the triangle, if your scale factor is bigger than 1, then your triangle is going to get bigger. If it's less than 1, it's going to stay smaller. If it's equal to 1, then it's just going to stay the same. All right, so let's look at some examples. In example 1, it says a triangle has vertices A 11, 2, B 10, 8, and C 6, 5. Dilate the figure using a scale factor of K equals 1/2. Graph both triangles. All right, so for each of these, you're going to see the rule or the algebraic expression, and this is just how you get from the point you're starting with, from XY, to the new point, okay, the dilated point. So here, since the scale factor is 1/2, we're going to multiply both of the coordinates by 1/2. So we're starting with XY. To get to our new point, we're going to multiply 1/2 times X, and then we're going to multiply 1/2 times Y. All right, so the image, because the scale factor is 1/2, okay, the image is going to be smaller. It's going to be reduced. So it will be smaller than the pre-image since K is less than 1. All right, and then after you look at the rule or the algebraic expression, which you will sometimes have to come up with yourselves, and then you can use a table to figure out the coordinates of the new point. So if I'm starting with 12, 2, then the rule, if I multiply 1/2 times 12 and I multiply 1/2 times 2, right? So if you forgot fractions, you can make it 12 over 1. That gives me 12 over 2. That simplifies to 6. Okay, or I can just take 1/2 of 2. 1/2 of 2 would be 1. Here, I'm going to do the same thing for each point. So 1/2 times 10 and 1/2 times 8. Half of 10 is 5. Half of 8 is 4. For C, I'm going to do 1/2 of 6 and 1/2 of 5. Now, 1/2 of 5, okay, is not going to be a whole number, but I can work with decimals. That's no big deal. So 1/2 of 6 is 3. 1/2 of 5 is 2.5 or 2.5. All right, so I want to make sure that I put both of my triangles on the map. So I'm going to start by graphing the pre-image. So 12, 2, I'm going to go over 12 and up to 2. And make sure you label everything. This is A. And then 10, 8. 10, 8 would be like right here. That would be B. And then C is 6, 5. So 6 and 5 would be C. So this is where my triangle is, how it originates or where it starts. Okay, and you can connect those. And then if I graph the new image after I've used the scale factor to find the new points, it's going to look like this. So I'm going to go over to 6 and up to 1. Okay, and then instead of calling it A, I'm going to use A prime. It's got that little apostrophe there. That's the just the symbol that you use for the new image. So, and the way you say it is A prime. And then the new point for B would be 5, 4. So I'm going to go over to 5 and up to 4. Okay, and so that was B, so now I'm going to call it B prime because it's in the image, the new image. And then C would be 3, 2.5. So 3, and then between 2 and 3 would be C prime, right? And so then if I draw my new triangle, I can see that it did reduce, okay? it did shrink, which you want to make sure that's one way to check it, right? If its scale factor is less than 1, then that's what should be happening. All right, so we're just going to repeat that. Same process for example 2. A figure has vertices f -1, 1, g 1, 1, h 2 -1, I -1, -1. Graph the figure and image of the figure after a dilation with a scale factor of 3. All right, so this time we're going to kind of fill in the rule ourselves. So if I'm starting with x, y, and my scale factor is 3, I need to multiply both of my coordinates by 3. So my new point is going to be 3 times x and 3 times y, or 3y. All right, so since the image is going to be, the scale factor is greater than 1, then this image is going to be getting larger, or bigger, or enlarged. So it will be larger than the pre-image since k is greater than 1. All right, so I'm starting with the pre-image. So f -1, 1, g is 1, 1, h 2 -1, and I is -1, -1. All right, so then I'm going to apply the rule to all of these. So I'm going to be multiplying times 3. That gives me -3, 3. Okay, and so this would be the point f prime. And then g would be, I'm going to multiply by 3 as well. So I'm going to get g prime, which is 3, 3, both positive. H, multiply them both by 3 again. That would be h prime is going to be 6, -3. And then if I multiply both of these for I, I'm going to get I prime, which is -3, -3. Okay, and then I need to put these on my graph. I'm going to start with my pre-image -1, 1. So I'm going to go over -1 and up to 1 and label that F. And then G is +1, 1. So G. 2, -1. I'm going to go over to 2 and down to 1. That would be H. And then -1, -1 would be right here. So that would be I. So I can see this is making a quadrilateral like this. All right, and then I want to go ahead and do my image now using the scale factor. So f prime is -3, 3, so that would be 1, 2, -3, and then 1, 2, 3 would be right here. This is my new f, or f prime. G prime is 3, 3, so 1, 2, 3, 1, 2, 3. It's right here. H prime is 6, so 1, 2, 3, 4, 5, 6, and then -3, 1, 2, 3. Is H prime, and then I prime is 1, 2, 3, 1, 2, 3. I prime is down here. All right, so then if I connect my points, I can see still got the same basic shape, right? Only it has gotten larger. Okay, so think about dilations being like if you've ever been to the eye doctor and they dilate your pupils, what happens is they make that pupil bigger. So this is just a dilation like that. All right, so here you're going from when the scale factor was less than 1, remember you're going this direction, so it got smaller. Here you started smaller and the scale factor was greater than 1, so it got bigger. All right, so since dilated figures have the same shape as their pre-image, okay, so the same basic shape, but they're just not the same size. So they have the same shape, but they're not the same size. Then they can be known as similar figures. So we talked about similarity. It's just a type of similar figure. Okay, all right, so if we look at the next page, in example 3, it's asking, or it says, through a microscope, the image of a grain of sand with a 0.25 millimeter diameter appears to have a diameter of 11.25. So the microscope is enlarging it, right? It was really this image, but now it's made to look at 11.25. So what's the scale factor of the dilation? All right, so you should know that because it's making it bigger, my scale factor should be larger than 1. So that's one way to check your answer to see if it's reasonable. We're asked to find the scale factor, so it tells us to write a ratio and simplify. Notice in the ratio, the dilation is always going to go on top, divided by the original, which is always on bottom. All right, so the dilation is what I end with, all right, is the enlarged image in this case because it was bigger. So 11.25, and then the original is the actual grain of sand, which is 0.25. All right, and then I always want to simplify this ratio if I can. So I'm going to go ahead and tie bow it, top in, bottom out. So I'm going to move my decimal over as well. So I'm actually dividing 25 to 1,125. So 25 won't go into 11. It'll go into 112 4 times. And when I subtract, I get 12. Bring down the 5. 25 will go into 125 5 times. Okay, so that tells me my scale factor is 45 or 45 over 1. If you want to write it as a fraction, I can just use a whole number. So 45 is the scale factor. All right, in example 4, it says Miss Henley's, sorry, got a barking dog. Miss Henley's class is creating a web page for their social studies project. They need to reduce a scanned photograph, so it is 720 pixels by 320 pixels. If the scanned photograph is 1080 pixels by 480 pixels, what is the scale factor of the dilation? All right, so just like before, we're going to make a ratio where the dilation is on top and the original image is on bottom. So for this one, we are starting with the 720. So that's the original size. And then 320 is also the original size. Okay, and then we want to make it smaller. We're reducing it. So then the new size, let's see if the scan photo, oh, I'm sorry. They need to make it 720. So ignore that. So that's going to be the new image. It's starting as 1080. All right, and then this one is starting at 320, but we're trying to, oh, sorry. That's what the new image is, right? It's the new image over the original image. All right, and so the scan photograph started off as 480, so that's on bottom. All right, so then I want to simplify these. I could divide it, that would give me a decimal. I can also leave it, usually I know this is gonna be less than 1. Scale factor normally is written as a fraction. I'm gonna just simplify this as a fraction. I can see these both end in 0, so I can divide by 10 and make this 72 over 108. These are both even, so I can divide by 2. Get 36 over 54. Okay, I can keep going. I know that these are both divisible by 9. So that gives me 4 over 6. And then that, again, is still divisible by 2. And that gives me 2 over 3. So I can see this has a scale factor of 2/3. This should be the same scale factor. So just to double check my answer, I'm going to reduce it as well. So I can divide this one by 10 and get 32 over 48. Again, I can divide by, let's say, 2 again. I know you can divide by other larger numbers, but I just choose to do it this way. So 32 divided by 2 is 16 over 24. These are both divisible by 8. So if I divide by 8, then that's going to give me 2 over 3. So I can see that either one gives me the same scale factor of 2/3. So K is 2/3. All right, so that's dilation. It's the first transformation in this unit that we're looking at. Dilations either enlarge or reduce the image depending on the scale factor. So just ignore the other noise going on in the back of this video. So we got people in the house today. All right, thanks. See you in class.